So I'm going to walk you through some substitution problems, and I want you to write down some of these. So in the next assignment coming up right after this, you're going to turn in some notes that you've taken. So I want you to take two examples from this video, write them down on a piece of paper and kind of explain them a little bit. And then there's one example below this that's written out. I want you to copy that as well. So you should have three examples on your page that you're going to submit for the notes in the next assignment. So let's get started with this. Remember, when we said substitution, we talked about that in class. Like, what is a substitute? We're just putting something in, taking something out and putting something in its place, right? It gets replaced. Like a substitute teacher would come in for me. A substitute in a basketball game would go in for that person that you replace them, right? So that's really all we're doing. When we have an equation that has two variables, you can't solve it. It has infinite solutions. Any equation that has more than one variable would have infinite solutions. So really what we want to do is get it to a point where it has one variable. Well, how we can do that is by using two equations, right? I can use this one to help me get this one to one variable. Well, this says 2x plus 3y equals 10, so that is two variables. That's a problem. But this says y equals 5. So the good thing about this is you can take 5 and put it in for y. I mean, why are we allowed to do that? It's because that y equals 5. Y is 5. So we don't have to write y. We can write 5 instead because y is 5. We'll substitute it. We'll take y out and we'll put 5 in its place because it's the same. Okay, so we can just rewrite this as 2x plus 3. And now instead of y, we're going to open a set of parentheses and put 5. Okay. Now those parentheses just help you like sort things out, keep track of signs and everything, and understand that we're still multiplying here. 3 times 5, because it's 3 times y, so it's 3 times 5 now, because y is 5. And now you can just go through and solve this. Now we know how to solve this by simplifying first, right? 2x plus 3 times 5 is 15 equals 10. Then we get all the variables on one side, so they already are. Then we want all the numbers on the other side. So let's subtract, and you can see I will line these up. We had been not lining them up because they're not like terms, but these are like terms, so I will line them up. 2x equals 10 minus 15 is negative 5. And then since it's multiplication, we'll divide by 2, and x is negative 5 halves. Okay, so we have, whenever there's two variables, you're going to want two answers. Two solutions, one for each, because y is 5, x is negative 5 halves. So y is 5, x is negative 5 halves. Well, let's look at a different one. That difference is going to make more sense here in a sec, because we still want to get one of these guys to have one variable, right? The good part is this says x equals 3y plus 5. Now, it's not as nice as the last one. It said y is 5. You could just plug the number in. But still, it says x is this. And if our goal is just to get the equation to have one variable, then it still solves that problem. Because I can take that and put it in for x. Why x is because it says that's what x is. X is this. So I don't have to write x here. I can write this instead. Substitute it in, right? So go ahead and 2 open parentheses and put 3y plus 5 instead of x, right? I'm just subbing that in for x because they said that's what x is. Minus 4y equals 30. Now, good. I have an equation that has one variable, right? It no longer has an x. It just got a y and a y. So this is going to take a little bit of solving, but that's okay. We know how to do each one of these things. We know how to distribute this. 2 times 3y is 6y. 2 times 5 is 10, positive 10. And then we bring this negative 4y down because nothing happened to it. So this was first step, simplify both sides, right? Now we're not completely simplified because we have like terms. We got 6y's and negative 4y. So 6 minus 4, 2y plus 10 is 30. Now it looks a lot like the other one, right? I can subtract 10 from both sides. 2y equals 20. Divide by 2 on both sides. And y is 10. Now remember, we need two solutions, right? There's two variables, so it's one solution together, but we need two values for x and y. So we have what y is, but it never said what x is, right? In this last one, we were done here because it already said y is 5 and x is this, right? But here we say y is 10, but what is x? We don't know what x is yet. So really, this has to go back in up here. When this says x equals 3y plus 5, this has to go back in for y. Y is 10, so I'm going to replace that, right? So it's going to say x equals 3 times 10 plus 5. So it's just another little substitution because I need to know what x and y are. So 3 times 10 is 30, and 30 plus 5 is 35. Okay, so now we have it. X is 35 and y is 10. Two variables, two equations, and we figured out what both the variables are for this situation by just substituting, getting it to one variable, solving, and then using that to get the other equation to one variable and solve. Okay, one more example here. This says x equals this and x equals this. So it's kind of weird. Which one do I substitute? Well, it really doesn't matter, right? Because all I need to know is x is this, right? X is this, and I could put that in for x in the other equation. So instead of writing x, I'm going to write 4y minus 7, right? We're substituting. 3y plus 2. And because I put it right here, 4y minus 7 equals 3y plus 2. Right? So if you took this and substituted it for this x, it would say the same thing. It would say 3y plus 2 equals 4y minus 7. Well, it's just flipped around, but it's saying the same thing. It's saying that this is equal to this. Okay, and you've seen an equation like this before, right? I mean, we've worked with these. So let's get all the y's on on one side. So that cancels out over here, and we're left with y minus 7 equals 2. Then we need all the numbers or this constants on the other side. Y equals 9. Okay, well, y equals 9, and remember, we need one for each. So y equals 9. But we'll come back up here, and it doesn't matter which one you pick. 3y plus 2. X equals 3, but y is 9. So instead of writing y, I'll write 9. And x is 27 plus 2. X is 29. And there we go. Man, it sounded so intimidating. I got two equations and there's two variables. Oh my gosh, how am I going to solve that? It's not so bad, right? That's not so bad. You just take, it says one of the variables equals this, and you can plug it in for the other one. And then it looks just like an equation we've always solved. Okay, there's like a tad bit more work here at the end when you got to find the other variable, but I mean, this is not that bad. Right? You know how to solve this. All you got to do is get used to taking these guys and plugging it into the other variable. Okay, so at the end, if you didn't take notes as we went, go just rewind a little bit, pause the video, write these notes down, kind of explain to yourself. I would even, show that how you're substituting, maybe even write out like I'm substituting this value in for x. Just kind of mention to yourself, take a little note about what you're doing so you can explain it to yourself along the way. So you get at least 2. I gave 3 examples here. Write down at least 2 of them. And then there's one below this too that's written out. I want you to write that. That's going in for your notes assignment next.